You already learned this, but you're gonna watch me do it anyway. Aw. Well, it'll just cement it that much better in your brain, too. You just woke up. Good morning. It's going to be okay. And it's like, I love that someone was like, I'm an engineering student, and fractions, I'm still like, heh. And the reason why I think it's really important to cover fractions, no matter what level of mathematics you're at, is to get that reminder of what fractions really are and what we're actually doing with them. You know? Because it's very easy. It's very easy to get overwhelmed. It's very easy to lose the forest through the trees and be doing really complex things with fractions, but forget what you're actually saying and why it actually works out. And if you can't remember that, why bother? I took entire courses in college where I actually have no idea what they were about. I mean, I got a B+ in them, but I have no idea what I studied. I, to this day, don't know what Fourier analysis is. Did I get an A in it? Yeah. Do I know what it meant? No. And that's a problem, because what was the point? Aw, that's such a high compliment that a teacher likes my classes. Thank you so much. Also, can we get a moment for my mug? I got it yesterday and I love it so much. It is hard, but you know what? I would say that anything hard is worth doing. Anything that's hard is still worth doing. Thank you. Yeah, I always joke, like, people are like, oh, are you excited for Halloween? And I'm like, yeah, that's when I get all my decor. It's just the casual month where how I dress is just typical. It's like I'm normal for a month. Yeah. Oh. All right. You sent the live to your math teacher? Oh no, now I'm gonna get judged by math teachers. We're going to talk about that today. We're going to talk about how to divide fractions. And you know what? It's actually one of my favorite things to do with fractions. Like, you guys are all like, we get like in this place where we're like, oh, adding and subtracting is the easy thing to do with fractions, right? Because adding and subtracting is so easy. Those are the things we're comfortable with. Those are the things we like. But actually, we already covered the hardest thing with fractions. Adding and subtracting fractions was the hardest part of fractions. Now's the easy stuff. Now's the stuff that's going to be so simple. You're going to love how easy it is. You're going to absolutely adore it, okay? So let's do this. We're going to do a quick reminder of what a fraction is, what it's saying, and then we'll get into that nitty-gritty. Protein bar. I am present, Mike. Welcome to the class, listener. In cosplay. I love it. Like, listen. You want to know how to engage your students? It's cosplay. That's where it's at, buddy. Alright, so reminder on fractions. Who knows what we call the top of a fraction? What do I call the very, very top part of a fraction? What is it called? What is it called? What is it called? You guys are all so beautiful and wonderful and great. It is my numerator. The numerator goes on top. Numerator. I'm not the best at spelling, so we're gonna go with it. I'm also what if I asked you that just to check the spelling of it? That'd be hilarious. And sneaky. So sneaky. I'm your favorite pro hero? Blush. Thank you, little listener. All right. What do I call the bottom of my fraction? What is that? What is that? The bottom. Beautiful. So smart. You guys are great. It is my denominator. Denominator. I mean, it's right if you don't sing, but it's more right if you do sing. So the top of my fraction, we're going to be talking about them and using these terms, and that's why we go over it. The numerator is my top, the bottom is my denominator. And what a fraction is actually standing for is, let's say I had 2/3. What a fraction is actually saying is that my top of my fraction, my numerator, is how many slices I have. How many slices? It's enough slices. I've got 2 of them. And the denominator is simply saying, how big are those slices? How many slices make the whole thing? How many slices are in a whole? That's all it's saying. The numerator is how many pieces you have. The denominator is how big they are. That's it. Never lose track of that. Always come back to that. The top, the numerator, is how many slices. It's enough slices. And the denominator is how big they are. That's all. Beautiful. Your new favorite math teacher. Aww, thanks. All right, let's move on to then how. How in the heckity heck do I multiply them? Oh, it's so easy. You guys are gonna love this. It's so easy. You're gonna adore this. You're panicking right now. You're like, oh, multiplying fractions is gonna be so crazy and hard, but it's gonna be so easy. Are you ready? Are you ready for the secret of multiplying fractions? All I'm going to do, thank you for the roses, my dear, is, let's say I had, I don't know, 1/2, we'll keep it simple, times, I don't know, 2/3. Does anyone want to take a guess at what I do? Aw, Hawks is your favorite, but I'm your hero, sweetie. You just multiply each of them. No, we're not cross multiplying. We're just straight up multiplying. It's so easy. If you're all overthinking it. You're just overthinking it, because all I'm going to do here is go multiply straight across. 1 times 2. 2 times 3. What do we get? 1 times 2 is just 2. What's 2 times 3? 2 times 3 is just 6. Are we done? We're not done yet, because as someone pointed out in the chat, I can reduce. And we always reduce, reuse, and recycle in this household. So let's reduce that fraction, shall we? We've got 2, 6. What can I reduce that by? What do I divide 2 and 6 by? Yep, you guys totally got the answer. You guys are great. Yeah, I can reduce by 2. Let's do it. I can divide 2 by 2. I can divide 6 by 2. So we're going to do it. Divide by 2. Divide by 2. And as people were saying in the chat, it's going to be 1/3. And that's it. We did it. It's 1/3. That was easy. That was so easy. All I did is we multiplied across, and then we reduced. Now you see, you could have done that, couldn't you? You love the singing. I wish I could say the singing was a show, but that's what I actually do in my classroom too. With mixed reviews. All right. Shall we give it another try? Let's give it another try. Oh, a leaf fell outside. I'm easily distracted. Let's do it. All right, let's do... Can you guys still see that? I can bring it down. Let's do, I don't know. Six eighths times 2/5. Give that guy a try. Give him a try, and then we'll check our answer, okay? And I'm gonna take another bite of my protein bar. I'll be looking in that chat, see how it goes. And as I would tell the kids in my class, feel free to use a calculator right now. Don't let that you don't know what 8 times 5 is hold you back from getting the concept, okay? Feel free to pull out that calculator and do this individually. Try it out. And then remember to play around with, can it be reduced? Can it be reduced? What can you divide both numbers by? Because I'm seeing some beautiful answers, but oh baby, can they be reduced? Oh. Also, a reminder to everyone in the chat, I am non-binary and my pronouns are they, them. So you can refer to me as those. Or when I'm in cosplay and I'm cosplaying a dude, you can refer to me as he, him. Looking good, my dears. Ooh, I love that someone did it in word form. Look at you go. Nice. That's okay. Heck yeah, non-binary present Mike. All right. We always reduce our fractions because think of it like, you know how when you're writing in English, sometimes there are very specific ways that you do things, right? Like the period goes here, the comma goes here. We write a question mark if it's a question. In mathematics, mathematics is ultimately a language to communicate as well. And so we have very specific ways in which we do things as well. All right, so we might reduce the fraction simply because it's easier to read what it is. If I have something like 10 1/100ths, that might be harder to understand than at the quick glance seeing 1/10. 1/10 is much clearer to me. So we always reduce our fractions when we are doing our final form. Because if I'm sending my results to someone, right, if we're using the math as a tool and I'm sending my scientific results to someone, or if I'm giving someone a measurement in which to measure something, the most reduced, the smaller the numbers, the easier to read, the better for everyone involved. So that is why after you calculate, you reduce those fractions. All right, let's go. That's okay to use a calculator. Like I said, don't let that hold you back from getting the concept, because the more you use the calculator, the more you put in 8 times 5, the more you'll remember it, and the more you won't need a calculator. So don't get held up on that, okay? Use your tools. All right, I do 6 times 2, right? Because I am just multiplying straight across. That's all I'm doing here. Gosh, that was easy. That's like what I wanted to do with adding fractions, and I couldn't. I love multiplying fractions. All right, I get 6 times 2, which is 12. I do 8 times 5, which is 40. And by God, I can reduce that number because I can tell right away that they're divisible both by 2. And I always do that. If I look at it and I go, well, those are both even numbers, you know you can reduce by 2. So keep that in mind. But there is a bigger number by which I can reduce 12 and 40 by. But if I didn't know, so you know what, I'm going to take this as if I didn't know there was a bigger number. And I'm going to reduce by 2. I'm going to pretend that I don't know. And that's the first thing I saw. And I always go, you know what, go with the first thing you saw. So 12 divided by 2 gives me 6. Sorry, we're getting a little muddled here. 40 divided by 2 is 20. By God, those are both even numbers again, 6 and 20. Well, I can reduce those by 2 again. So double check. If you reduce, try reducing again. Can you reduce again? Reduce until you can no longer reduce. And I always say go with what you first see and just see from there. Is it going to take more steps? Yeah, but is that necessarily a problem? I don't think so. It still got you there, didn't it? So 6 divided by 2 is 3. 20 divided by 2 is 10. And I get that my final answer is 3/10. Nice. Good job, everyone. You're so wonderful and good at this. I'm proud of you. And if you don't get it yet, that's okay. It's okay to not get it yet. All right, we're gonna try it again, and then we're gonna talk about what we do if, like, we have a mixed number, okay? And then we're gonna talk about dividing fractions, which dividing fractions seems like it's gonna be a lot harder, but it's really not that harder. Words are good. And then we'll talk about why dividing fractions works, okay? Cool. Let's do it. Oh no, gotta erase the board again. Where is my husband when you need him? Am I right? Eraser. Ugh. Oh wait, he's not that kind of eraser? Dang. One day that joke will get old, but it's not today. Erasing the board. Also, if you're looking for my adding fractions video from a couple weeks ago, it didn't get up on my YouTube because for some reason it didn't get saved to TikTok, so I wasn't able to save it and put it up. I'm going to try and record another one for y'all and put that up because that's a very good lesson to have. And I find it's one that a lot of people need a refresher on. So stick tight, that one will come eventually. Hopefully it records this one today and we don't have that same problem. TikTok. And if you don't follow me on YouTube, you can find that in my bio in my link tree. Also, you could probably just search Thistle Witch and find it, honestly. Thank you for the hearts. I mean the hearts, the roses, honeys. Yeah, I need to get some spray for the board. We'll work on that. Oh, thank you for the finger hearts. This app has totally ruined me. Someone like did something for me in real life and I was like, hey, thanks. And I was like, nice. Oh, you're sweet. You guys are all so sweet. Yes, we'll be getting to the keep, change, flip, and we'll be talking about why the keep, change, flip works, which I think is the more interesting part, don't you? All right, but first, let's quick do something. If I have a mixed number, how do I deal with that situation? Get some of my hair out of here. Oh, it's so beautiful and long, but it's so in the way. Okay, so here's what I do if I have a mixed number. Let's say I've got, I don't know, 1 2/5 plus, I mean not plus, we're doing multiplication today, I'm winning. Excuse me. 2 1/3. Let's say I have this. Huzzah. Sorry that my lighting's weird. You know what, just a second, let me try something. helped a little. Way better. Great. You can like see the background. All right. Awesome, awesome. Yes, 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 yes. You guys are killing the game. You guys are so smart and wonderful. You know that? You guys are so great. Awesome. Yes, exactly. So how I changed this is first what we're going to do to multiply these. There's actually several ways you can do it. But I like this way because it's always going to work. So I'm going to show you that way, okay? We're going to first change them to be improper fractions. Improper, so improper, but improper fractions have a time, they have a place, and we'll use them now. An improper fraction is when the numerator is larger than our denominator. So improper, she can't go out looking like that at the end of the day, but we can casually be in our sweatpants around the house, right? So we're going to use that now, and then we'll fix it later if it's still improper, okay? So here's how you switch it to an improper fraction. And this is where we're going to keep in mind on what a fraction actually is, because if you remember what a fraction actually is, it's very easy to think your way through how to do this, even if you forget the steps. That's why I say always remember what you're doing, because then you can derive the steps yourself instead of just rote memorizing what's going on, right? So let's do that. Let's think about what this says. What this says right here is that I have 2/5. So my slices are 5. I need 5 slices to fit a whole, right? I have 5 slices to fit a whole, and then I have 2 of those. So if I've got a whole, that means this was 5 slices, right? This guy was 5 slices. So I've got 5 slices, and then I've got an extra 2 slices, which means altogether I had 7 slices. Those slices are still just that big. Nice. Then here, this is saying that I have the size of the slices are 3. The pizza's cut up into 3 pieces to fill a whole pizza. I have 1 of them, and here I had enough to fill 2 whole pizzas. So let's see, how many slices would it be to fill 2 whole pizzas if they were cut into 3 slices each? Well, my God, that'd be 6 slices. And then I've got the 1 slice, so that ends up being 7. They're both 7. That ends up being 7 slices that are cut up into 3 sizes, right? That's what that's saying. That's how we got there, is we just thought about, yeah, right, this is easy. Oh my gosh, that's my favorite thing to hear in math class is going, wait, that's not that bad. Wait, that was actually easy. When we get caught up in the steps, right? When we get caught up in what the steps are and how I go step by step and what the rule is, that's when it gets hard. Because no one can fill their brain with all of that. We really can't. I am not filling my brain with what the steps are. I'm filling my brain with what am I actually describing? Because then I can forget the steps and then I can remember like, oh, that's what that's saying to me. And I can make the steps up myself, and you can too, because you're smart and beautiful and wonderful. Don't feel like you are dumb because you can't remember every single little step everyone's ever told you about mathematics. Nobody can do that. I'll repeat that again. Nobody can do that. You are not dumb. What people are doing is just remembering what it means. You're not dumb. No one can do that. It's okay. So we're just going to try and keep in mind what it's actually saying to us. And then we can figure it out. Also remember that it's okay to play with your mathematics and it's okay to be wrong. I'll repeat that again. It's okay to be wrong. I spend most of my time in higher level mathematics being wrong. And that's okay. What's not okay is stopping. Persist. You've got this, okay? It's not about the IQ. It's about the I can. It's about the drive. And you've got the drive. You can do this. I believe in you. All right. So we got our fraction to here. So let's multiply across like we do. 7 times 7 is 49. 5 times 3 is 15. Oh my god, that's an improper fraction. So we can't... Oh! Thank you for the heart, honey. Oh, those are always so cute. So this is the part where I said we'll have to rewrite it, right? And again, it is okay. It's okay to use a calculator, because you want to know what I would do right now? I'd use a calculator. I would use a calculator to figure this out. I have a master's degree and I would use a calculator to figure this out, okay? All right, so we are going to take the 15 and I'm going to ask myself, how many times can I take 15 out of this? How many times am I going to fill up that whole pizza if my slices are 15? I can take it out, and I only know this because I saw it and I was like, oh yeah, that's it. Is I can take it out 3 times. I can also think about it as, okay, I've got 15 plus 15, that's 2, that's 30. 15 plus 15 is 30. Okay, add another one. Oh my god, am I using my fingers to count? I am, that's okay. If it works for you, it works for you. All right, so add another 15, that's 45. I can't fit another one in, but 45 fits into 49, so I can take it out 3 times. 3. My slices are still the size of 15, right? I have not changed how big my slices are. All right, what am I left over with if I've got 45 and I take that out of 49? 49 minus 45. (49 minus 45). Beautiful. It's 4. Nice job, my dears. And my last step is to ask myself, can I reduce 4 over 15? Can I reduce 4 over 15? I can't. I can't. There's no number that I can nicely divide 4 by and 15 by, right? I can kind of like, if I was unsure, I could guess and check. I love guessing and checking. Try it. Do it. It's okay. I can divide 4 by 2, but I can't divide 15 by 2, so that doesn't work. I can divide 4 by 4, but I can't divide 15 by 4, so that doesn't work. So we're done. That's it. That's our final answer, 3 4/15. Nice job. Also, we're not going to judge anyone in here for not being able to do fractions, right? Because there's a lot of things I can't do. There's a lot of things that I'm not the best at. I'm dyslexic. That's okay. I just find different ways around it. Do I let that stop me? Absolutely not. Do I need more reminders on it? Absolutely. That's okay. That's okay. Also, please keep in mind that, like, if you are, like, looking at me and you're going, wow, you're so good at math, this is all I do. All I do is mathematics. My brain doesn't have to focus on so many other things. Whereas when you're in school, you're having to learn about so many different things. Whereas I only have to focus on mathematics. Of course I can keep some of the little things more straight. I'm not worried about social studies or English right now. Kind of funny because I'm dressed as Mike, but you get my point. Oh, how to make a fraction into a decimal, sweetie? Pull out your calculator. All you're going to do is do the numerator divided by the denominator. That's it. And that'll give you a decimal. Just numerator divided by denominator. And that's all she wrote. And that's your decimal. Hope that was helpful. All right, let's talk about, yes, let's talk about division. Let's talk about multiplying fractions and dividing fractions. Let's talk about it. I'm so excited for this. Let's do long division. There is a video up on my YouTube for long division. So please go there to find that, okay? But we're not going to cover that one today. Today we're going to talk about dividing fractions because that sounds so scary. It sounds so scary, right? Because we're talking about fractions and fractions are scary, and we're talking about division and division is scary, but my God, it's not actually that scary when we put them together. Okay? It's not going to be that scary. And like I said, I'm right here with you. I'm doing my exponents homework. Are you one of my students? Are you one of my actual students? That's funny. Good luck on your exponents homework. Let me know if you need any help with it, okay? No, you're not? Okay. I have an exponent assignment out right now. That's why I thought that was funny. I was like, you one of my actual kids? One of my in real life students. All right. Let's get it. I'm going to erase this actually so we just have division up on the board. And I'm going to be asking y'all some questions to come up with how we do division, okay? So you're actually going to help me come up with why and how we divide fractions, because you guys have all the answers. You didn't know it, but you do. You didn't know it, but you do. For some reason, I just got a Cher song stuck in my head. But that's life now, isn't it? All right, dividing fractions. Let's do it. All right, so my first question, okay, I'm gonna put a problem up. Let's do 1/2 divided by 2/3. We're just going back to that example. But we're doing division this time. Let me draw the division sign a little bigger so you can see it. Divide, we're dividing. Great, great. All right, so now here's my question for you all. What is the opposite of division? What is the opposite of dividing? What is the opposite of dividing? Wonderful, 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 my dears. You got it. It's multiplying. The opposite of dividing is multiplying. Perfect. Perfect. Some people are putting adding, and I can see why you think that. I can see why you think that. I love that as a wrong answer. But the opposite of adding is going to be subtracting, right? If I give it, I take it away. Multiplying, if I multiply it, I divide it. Those are my opposites. Mathematics is all about opposites. All right? So, a lot of you are naming off like the hard and fast rule for remembering this, but let's talk through how to get there, okay? So keep that in your head for now. Keep that hard and fast rule in your head for now, okay? Don't type it in the chat for now. Just keep it in your head. All right, so the opposite of dividing is multiplying. Great. Well now, see, here's the thing. Because I want to multiply, I want to multiply. I want it so bad because multiplying fractions was so easy. I loved it. I loved multiplying fractions so much. I loved it. So let's make it multiplication. But here's the thing. Because I multiplied instead of divided, I did the opposite. I have to do something else the opposite. Because in mathematics, it's about balance. If I do the opposite of one thing, I must do another opposite to compensate for that, to make it the same thing again. If I take away, I need to give back in order to make it the same thing. So if I do the opposite of multiplying, I have to do another opposite in here. So the opposite of dividing by 2/3 is going to be multiplying, doing the opposite of the opposite fraction. And the opposite fraction of 2/3 is if I flip it on its head and do 3/2. So I just flipped this guy over. I tumbled him around to make him the opposite fraction. And that's where a lot of people were saying in the chat. A lot of people were saying, oh, it's keep, change, flip. It's keep, change, flip. And while I like that you remember that rule, I also don't like it. And let me tell you why I don't like it. I don't like it. And I hope you are listening while you were writing that. Because keep, change, flip tells me nothing about why I did it. It tells me absolutely nothing about why I did it. And we just talked about hard and fast rules, didn't we? In that you're going to forget them. Naturally, you're going to forget it. And that's okay. But remember why it works. Because if you remember why it works, you'll always remember it. Okay? If you remember why it works, then you will remember how to do it again. You can derive the rule yourself. You don't have to remember the rule because you can derive it, because you have that power, okay? And I saw in there, why didn't we change the first one? And that's a great question, and this is how to think about it, okay? We kept this first one because this is the one that we're doing stuff to, right? We are doing stuff to the first one. We're doing stuff to the first one. What am I doing to the first one? The first one, I'm saying 1/2 divided by 2/3. I'm saying this thing divided by something else. So this thing's going to stay the same because this is the thing that's getting that action, that stuff's happening to. What's that stuff? First it was dividing, but I went, no, division. I don't like you, not today. I am going to flip that around. I'm going to do the opposite. So if I do the opposite, I do divide, I turn it to multiply. I did the opposite. And since I did the opposite of that, I have to even that out by doing the opposite fraction. And I get the opposite fraction by flipping it upside down. So if keep, change, flip helps you, sure, that's great. But I hope you remember why it works, okay? I hope next time you do it, you go, it's because I'm balancing opposites. Because if I balance opposites, they're going to be even. Because like I said before, there's no point in doing it if you don't know why you're doing it. There's no point in doing it if you don't know why you're doing it. Okay? So let's solve this guy, shall we? We've flipped him around, we've made him a much easier problem. Most of mathematics is just making it an easier problem. Let's multiply. 1 times 3 gives me 3. 2 times 2 gives me 4. It was 3/4 the whole time. Nice. All right, I'm going to give you guys some, and you're going to try them, okay? I'm going to give you some, and you're going to try them. Going to keep this example up. Let's do, I don't know, 2/5 divided by 3/7 and 6/7 divided by, I'm not giving myself enough space to work, 6/7 divided by, I don't know, 1/10. Go for it, my dears. Try these two out for size, shall we? And then we'll talk about them. And remember, it's okay to try them and get it wrong. Because if you get it wrong, even if you tried it, you're going to remember the answer that much better. I'd rather you try it and get it wrong than do absolutely nothing right now, okay? Give it a try. I'm going to have another drink of coffee and another bite of my protein bar. Ooh. Snack break. Yep, always simplify if you can, and always write it as a mixed number if it ends up being an improper fraction, okay? Always put them in their final forms. It's okay to be stuck. Got as far as you can, sweetheart. And put your best guesses out there. I'm seeing some beautiful answers out there, my dears. Protein bar. I'm also seeing some really beautiful wrong answers because I can see how you got them. And it tells me that you're getting it a little right. So good for you. Math is hard, but anything that's hard is worth doing. Anything hard is worth doing. Also, if it was easy, then you just weren't pushing yourself hard enough now, weren't you? So it's a good thing it's hard. It means you're pushing your limits, and I'm proud of you. A drink of coffee and we'll start to go over them. Okay, my dears? Good work. I'm proud of all of you. Oh, Murder Maven showed up. I laugh because Murder Maven loves to block people and thrives off of anyone who's being too sassy. Yeah, coffee. All right, let's do it. Let's do it. Let's do it. Let's do it, do it, do it. All right. I saw some beautiful, beautiful answers in there. I'm so proud of you guys. Wait, I actually have a class. I love when people in here are like, are you a math major? You're really good at this. And it's like, I was like 10 years ago. You flatter me. I'm good at this because this is what I do for a living. All right, so let's talk about it, all right? We want to make this something nice and easy. Division is, I don't want to divide. I want to multiply. Multiplying fractions was so easy. It was so easy, I loved it. So let's do it. And remember, I'm doing it to this fraction, so we're changing everything else. I keep my 2/5. And I want to do multiplication, which is the opposite of division. So I'm going to multiply. And if I do the opposite of division, I have to use the opposite fraction to keep everything nice and even. So it becomes 7/3. I just flip that sucker on its head to make it the opposite fraction. I did the opposite, so I have to use the opposite. Now I can multiply like normal. Huzzah! So 2 times 7 is 14. 5 times 3 is 15. Can I reduce 14 15ths? No, I absolutely cannot. I absolutely cannot. So I just leave that as is. Nice. We're done. That was easy. Remember, I did the opposite, so I used the opposite. Opposites and opposites cancel out. How nice. How convenient of them. All right, so let's do the next one. The next one gets a little trickier. Trickier. I'm the best professor, Mike. Oh, thank you. Also, I'm wearing the tie that Murder Maven gave me. Thanks, buddy. I love it. Makes me feel sassy and pretty. All right, so 6/7. I'm doing the stuff 2 6/7. I'm dividing 6/7 by 1/10, so that's the one that I keep. Because that's the one that stuff's happening to. Stuff is happening to it. I want to multiply, so I do the opposite of division, I multiply. Because I'm doing the opposite of division, I have to use the opposite fraction. To get the opposite fraction, I'm just flipping that sucker on its head to 10/1. Nice. Now I can multiply. Multiplying's easy. All right, what's 6 times 10? It's 60. What's 7 times 1? It's 7. But my God, am I done? Am I done? No, I'm not done. I'm not done. Because why? Why am I not done? This is what we call an improper fraction. So improper, she's in her sweatpants right now. We can't let her leave the house like that. We need to snazzy her up a bit, right? We need to snazzy it up a bit. So we need to write it as a mixed number. Right now it's an improper fraction. So improper. We need to redress her. She's going to be the same beautiful fraction, but in a whole new getup. So let's do it. How many times does 7 go into 60? How many times can I make a whole out of 60 with 7 slices? It's okay, and it's okay to use a calculator right now to see. I would do 60 divided by 7. I'm gonna get 8. Awesome. The size of the slices are still the same, and now my question becomes, what's 8 times 7? What is that? What's 8 times 7? 8 times 7... 56. Beautiful. Beautiful, beautiful, beautiful. So I took 56 out of 60. That's what I did when I took those 8 out. So what's left over? If I take 56 out of 60, what's left over? Awesome. 4 slices remain. So I have 8 and 4/7. And that is my final answer. Final answer. Oh, someone's from the Midwest there. Nice job, my dears. Nice job. And remember, if you didn't